Today's question will apply basic knowledge on electric field. There are 4 charges in an isolated system, 2 on the x-axis and 2 on the y-axis. Those on the x-axis are as follows. Positive 6 microcoulombs 4 centimeters east from the center and positive 6 microcoulombs 4 centimeters west from the center. On the y-axis, positive 3 microcoulombs 5 centimeters north from the center and negative 8 microcoulombs 7 centimeters north from the center. With this, what is the net electric field at the center?
To better understand the scenario, we have to illustrate it for a better visual understanding. Then we figure out with the given and they ask what formulas we're going to use. We're looking for the net electric field, which is basically the summation of all electric fields at a given point. To find the electric field, we multiply Coulomb's constant, this number, with the absolute value of the charge in coulombs, divided by the square of the distance from a given point in meters. We're assuming that there will be a test charge at a given point to test for the field, and that said test charge is always positive so we can determine the field's direction.
Since there are 4 separate charges that each influence the electric field at the center, we can make separate E equations for each charge and substitute the variables appropriately. Since the center test charge is always positive, we consider how each individual charge affects it. Since the first charge is positive, it is repelled. The same goes for the others, second repelling, third repelling, and fourth attracting, as they are positive, positive, and negative respectively. After we find the numbers, we add the vectors by separately adding the x and y components. Since the x values are equal in magnitude but opposite in direction, they can be cancelled out. In that case, we cancel the x values and add the y values. This will get you an answer of 3.9 times 10 to the power of 6 and c towards the positive y direction. As such, if you place a charge of positive 1 coulomb in the center, it will experience that much force in newtons to the positive y direction, though we won't get into that.